Thank you, and thank you for the invitation to come here to your seminar. I hope you have had a good start for the growing season. In Finland, it has been a little bit slow, cool and rainy, but I think it's much more better than dry and hot springtime, which we had, for example, last year. So it's much more better if you have to choose between these two. My name is Sari Peltonen. I come from a ProAgria advisory organization where I work as a crop production development manager. And yes, I'm here to talk about the significance of liming. What does it mean in soil health and in crop production as general? First, just one slide for ProAgria. What is it? It's an agricultural advisory organization like you have here, LLKC. Yes, and we are the biggest kind of neutral advisory organization, independent organization in Finland. We have total of 650 persons, from which advisors about 300 to 400, crop advisors about 125, and we are spread all over the Finland. We have 11 rural centers and then the kind of headquarter where I am working very, very south in Finland, and we have over 100 sites where the advisors are giving services to farmers. And our services are used by 85% of our farmers, if you include all those trainings and plant protection examinations and all those things together. Yes, but then we are going to this important issue of liming, and when thinking about our crop production services, there has been a very long time focus on soil health and crop rotations, and that is because we have had behind very long period of monoculturing cereals, and it has raised now problems which especially escalate in extreme weather conditions, too wet, too dry. So something has to be changed, and therefore the focus has been more than 20 years already on soil health, soil structure, soil microbes. And we have had, as I mentioned in the beginning, extreme weather conditions in recent years. We have had very dry early growing seasons and then very, very wet harvest seasons. So the rain comes totally in wrong time, maybe you can say that. And therefore good soil structure is very, very important. It supports the root development, and it is very important that the roots can grow deep so they can survive the dry periods better, and they have tolerance to drought increase. And where it comes the significance of this soil structure, so that the roots can develop deeply. Farmers are asking that why don't we have drought-resistant crop varieties, but maybe it can also raise a question that why do we improve the soil structure? That may be the more easy way to handle this situation. And practices to maintain a good soil structure and fertility, there are plenty of them, and I think the most important is a good drainage system in the fields, and to manage it. It's not enough that you have a drainage system, you have to manage it, pure it, take care of it. Then soil analysis. That's very important. In Finland, it's a part of agri-environmental subsidies. This measure that farmers, you have to take soil samples every 5th year, and 95% of farmers are included in that system, and they take soil samples. And liming, that's I come it later, but that's very important in Finland. We have naturally acid soils, and to achieve the target pH level is very important. And then also the other methods, avoiding soil compaction, what kind of tillage methods we have, crop rotation, use of cover crops, increasing soil organic matter, use of green manure. These are the routine lists of measures to maintain good soil structure, and liming is one of the important measures inside these things. But field water management is, however, the number one. It's the basis for crop production and plays a crucial role in improving the field productivity and reducing nutrient leaching. And this proper land drainage system, it is essential before other basic field improvement measures can be done, and it's the basis that the cultivation practices can yield the necessary benefits. So it's the question that the excess of water goes out easily, and on the other hand, can the soil restore enough water? That's the number one field water management system. But liming of soils, it comes very next. It's the must number 2 in Finland. The soil is naturally acid in Finland, and to increase pH level, it improves the availability of nutrients, almost all nutrients to crop plants. And liming also improves the soil structure and microbial activity. And lime is also fertilization of calcium and magnesium. And it's really crucial to have even moderate but better yields. And there's one thing that liming has usually been done during the winter when the fields are frost, and it's very kind of natural to do at that time of year, so you don't cause any compaction and that kind of things. But now, when winters in Finland have also become milder, it challenges the optimal spreading time, and there is now a little bit talk about that how can we cope with this, and should we move to kind of summer spreadings and that kind of things. But that's one issue that we now have to take into account more and more. And economy of liming. I would say that all professional farmers, the liming is the very basic cultivation measure which is done. Liming costs is approximately 300 euros per hectare. It includes transport and spreading. And if you calculate that the effect of liming lasts about 5 to 6 years, so if you divide it by 6 years, it comes 50 euros per hectare as a cost. So what is the yield increase required to cover these costs? It is at the price level 200 euros per ton. It's 250 kilograms per hectare, for example, cereal yields. And based on the experiments, typical yield increase after liming is 10 to 20%. And if you calculate the average of 15% increase at the yield level 4 tons per hectare, which is typical in Finland, you can get 600 kilograms per hectare. So if you compare these two figures, liming is profitable. But there is also this challenge, as in the previous slide. The challenge is the big share of rented land in Finland and short renting periods. So farmers are not so willing to put inputs to the rented fields, especially if the renting time is 1 or 2 years, unless the field owners contribute somehow. So this is a challenge, and now we have trying to give solutions to this, and kind of that this has to be taken into account at the price, the rented price level, or have to be agreed between the field owner and the farmer, so that the farmers are more willing to do liming also on the rented land. But I know, and we know, farmers in Finland, so even though what is the renting time, they are doing the liming because it's really the basic crop cultivation measure which has to be done and which has to be taken into care. So a few words about significance of liming. So pH, it's not just an increase in pH level. You have to remember this. It has also other positive effects, biological effects, and physical effects, improve soil structure, chemical effects. Few words about it: improves this cation exchange capacity, and economical effects, as I previously mentioned. And it is said that if there is no liming, there is a risk that 30% of nutrients in fertilizers are not coming available to the crop plant. So why the soil is acid? Why it is getting acidic? There are kind of natural processes which are behind this. So when the plants uptake nutrients, relevant nutrients to their growth, it liberates hydrogen ions, and that decrease pH at the soil level. And also this nutrient cycle, ammonium nitrification, it liberates hydrogen ions and decrease pH, and leaching of nutrients also decrease pH. But there are also processes which increase pH, and this is, for example, nitrate uptake, decomposition of plant residues, mineralization of organic material. So there are also opposite effects. But basically, use of nutrients by plants is the main cause of acidification of the soil. And of course, there is behind for example, in Finland, that the soil is naturally acid because it's derived from the acid stone material or minerals. So what does mean this cation exchange capacity? In fact, it means it's the same thing as soil fertility. So it kind of describes that what is the size of the kind of the soil surface which can accumulate nutrients. So it is optimal to have about, the figure is about 15 to 20. And if it's less than 10, it's not so good. And liming is one way to increase the cation exchange capacity. And it means that really that the nutrients, positive cations, they can stuck into the soil aggregates and being uptake by the plants. Here's also table showing that what are the optimal relations between, for example, calcium, magnesium, potassium, natrium. And it shows that in different soil types, what is the kind of most optimal relation between these nutrients. And you can find this information from the soil analysis. Therefore, the soil analysis is very important, and you have to look also other parameters than pH from the soil analysis. And one thing is to look at what is the ratio of cations, these nutrients. Just few words that what does it mean, for example, to have liming and to have a kind of more nutrient cations in the soil. Kind of this untreated soil, it means that the soil particles are surrounded by water and it keeps the structure loose, so it's very sensitive to silt and to have erosion. But if you add their cations, nutrients, for example, calcium, ions, it binds the soil aggregates together and make the structure very stabilized and firm. So, and it keeps the erosion very, very small, and it enables that the soil aggregates form more strongly and are resistant, for example, to erosion and excess of water and so on. And the same effect also can be achieved by the addition of organic material to the soil. So microbes starts to digest the material and secrete compounds that binds the soil particles strongly together. And this shows a picture where it has been no lime and then liming is done, and you can see that it supports the root growth of crop plants. Roots can develop stronger and deeper in good pH soils, and this ensures also very efficient nutrient uptake and also water uptake of crop plants. And I think this is very familiar, very basic chart, which shows that how the useful nutrients, how they are available in different pH. And as you can see, most nutrients are more available when the pH level is above 6. And then on the opposite, it shows also that there are harmful compounds and that they are more easily available when the soil is acid. And if you increase the pH, it usually makes them not available for plant, which is a good thing. There's especially in Finland, we talk much about phosphorus. So we can reduce phosphorus fertilization by increasing pH level, or if the regulation is so strict that it restricts you to use any phosphorus, you have to take into account that is your soil pH level good enough, and by increasing that you can have kind of naturally phosphorus available to your crops. Yeah, and here here what I just talked, that in Finland we talk much about the availability of phosphorus, and liming improves the availability of it. And in mineral soils, it has been shown by studies that 5 tons lime per hectare has made 50 kilograms phosphorus soluble from soils to the croplands during 10 years of period. And this is of course important, what are the pH demands of different crops. This is also, I think, very familiar to you. There's, I think, in top of the sugar beet is alfalfa. It is, I think, the most demanding plant for pH, so it should be over 7. And then there are sugar beet, malt, barley, wheat, pea, and so on. And potato is there, which is less demand for when it takes into a pH level. So this is also crucial, that what are you cultivating, so it affects that what kind of pH you are targeting in your fields. Yeah, then a few words about what kind of liming materials we have in Finland. I think you have it also. Here it shows a map that we have factories, lime factories, and then delivery points quite much in Finland, all over the Finland. And there are kind of 3 groups of lime materials. The first one is limestone powders. And we have 2 types of them. Calcium carbonate, also called calcite, and then calcium magnesium carbonate, also called dolomite lime. And if the magnesium content is over 10%, then you call it as a dolomite lime. So we have these kind of powders, 2 types of powders, and it can be achieved from different parts of Finland. And then we have granulated lime, and it is especially used for precision agriculture. So you can more accurately spread granulated lime. And then we have also, I think maybe this is increasing, calcite products from renewable sources, from liming factories itself, from pulp industry, paper industry. And then this, which we called structure or structural lime. So it means that it has this carbon carbonate, but it includes also small amounts of quick lime or slaked lime. So it means there is calcium oxide or calcium hydroxide, which are very, very reactive. They have kind of loose calcium ions there, which reacts very rapidly, very strongly in the soil. And it also means that when you use this structure lime, you have to make a tillage very quickly after the spreading, so that it can start to affect with the soil aggregates. Yeah, so kind of 3 types of liming materials we have in use. And then liming planning, how we do it. Firstly, if we get a kind of a new field plot which has been long out of cultivation, then it apparently needs basic liming. This means that we lime with big amounts, 10 tons per hectare, to increase the pH level, the basic pH level in the soil. But after that, and when professional farmers are using their farming practices, they usually perform routinely maintenance liming. We call it maintenance liming. And it means liming with smaller amounts, 5 to 7 tons per year, but in 3 to 5 years interval. So that's the kind of routine which professional farmers, they perform that as a routine crop production management measure. And then what kind of lime to use? There we need this soil analysis. We need to check that what is the calcium-magnesium relation, and what is the soil type, and what is the existing pH level. And then if you do soil analysis, usually the laboratories give you at the same time the recommendation for liming, but you can do it also in the internet websites. There are kind of liming calculators where you can choose what is the pH level, what is the pH level you target for. It depends on the crop, what you are going to cultivate, what are magnesium, calcium contents, what is your soil type, organic matter. And here it also asks that what is the nearest factory, liming factory, so it's also taking into account the transport costs, so it suggests the right lime product to you. So in fact it's quite simple to make this choice of lime, and it doesn't cause among the farmers not so much question. But of course there is also that you have to think about of this particle size and reactivity. So if you want to take these into account, so in fact you have to first think that what is the aim of your liming. Is it the purely neutralization, that means to increase pH, or is it also to balance calcium-magnesium relation, or is it to increase soil magnesium? And these other things to take into account are this particle size of the lime. So if it's very fine size, it's very soluble and affects very rapidly. And this reactivity in neutralization is also depends not only from the lime product, but it also depends on the tillage method, soil moisture, and what is the existing pH. And of course, you have to also think about these transport costs, and whatever you are using inputs in the soil, of course, it is very crucial that you have it spread very nicely, very even. And then here are some kind of key answers to how to take into account this calcium-magnesium relation. If you have enough calcium, it means that it stabilizes soil aggregates. If you have too much magnesium, it means that it can cause silting, erosion, especially in clay soils. And this calcium-magnesium relation, optimal anyway in Finnish condition, is 8. And then it doesn't matter what type of lime you use, but if it's over 8, then you have to use lime material, or it's better to use liming material which contain magnesium, or is named dolomite limes. And if it's under 8, then it is preferable to use calcite limes. Yes. And how fast liming works? Maybe also one typical question. And normally, target pH is achieved in 2 to 3 years. So this comes to the question that if farmer has very short renting period of fields, is he willing to do the liming, because then the advantages are not achieved by this farmer. And the effective period of lime lasts about 5 to 10 years, depending on the particle size. But as I mentioned, typically Finnish farmers do this maintenance liming maybe not every third year, but every 5th year. And about this particle size of liming materials, it affects the reactivity of limestone. So the green line is the finest, very fine granulated limestone. So you see it affects very rapidly and achieve the target pH, while the more coarse crushed limestone, it affects a little bit slower. But usually the liming material is both of these. So there are some more coarse material and then more fine material. And as you see in Finland, lime is pulverized so that it is more or less than 2 millimeters, but then half of the material is less than 0.15 millimeters. So there are kind of these rapidly affecting parts and then slower reacting parts. Yes, and I'm getting to the end of my presentation and just showing that what is increasing or has been more than 10 years, that you make a pH map of your field, and you do precision liming according to what the field needs. You kind of adjust the lime according to that, and you can kind of have a optimal situation. You can save liming material, but what is more important, that you can get the field variation in the field plot more even, and which is better then. And then we have had these kind of machines that sort of replace the soil analysis itself, this kind of optical scanning vehicles. And nowadays it has been a little bit more silent which comes to this machine, but hopefully there are not so many those machines, but some farmers or experimental farms have tried to use this and find out that if it's telling right things, so that it can kind of measure not from the crops. It should be a bare field, so it can kind of scan and measure the pH and also other parameters from the soil. But it is very interesting and very useful for the farmers if it really works and if it's not too expensive to use. Yes, I think that was my story to you about liming in Finland, and as I mentioned, we have focused very much lately on the soil structure, and it means that you also have this spade and go out there and dig the soil and examine the soil better to find out the structure and if there are compaction layers, and to find out that the field plot is producing as it should be, and to kind of reduce the variation in the field plot and get every inch of the field plot to produce more. Okay, thank you.
Thank you, Sari.
Paldies.
Perfect.
Oh, yeah, I learned it. Yeah.
So I kind of did
did see that many things that you do in Sweden we also do in Latvia, but
or Finland.
I'm terribly sorry.
Yeah.
We usually get very
friends.
offended when somebody says this about Latvia and Lithuania. So
Yeah.
But I've heard the joke that when you play ice hockey, it's not that important that Finland wins. It's important that Sweden loses, right?
Yeah, that's yeah.
But in Finland, we do sort of similar things here in Latvia. But I was very surprised that you do the liming during the winter, because I don't think that's common practice in Latvia.
Okay. Yeah, that has been the most kind of normal way to do it during the winter, but now we have to think it over because we don't have had so good winters anymore.
I lost my microphone, but I see a couple of hands for the questions. So 1, 2. Let's stick with 2.
Kaļķošana ļoti labi, ļoti vajadzīga, bet viena no kaļķošanas lielajām problēmām ir emisijas, jo karbonāti būtībā, visbiežāk jau tiek lietot karbonāti, tas pa lielu būs CO2 emisijas. Vai par to Somijā domā, kaut ko dara?
Soil liming is very good, but one bad aspect of that could be CO2 emissions. Are you thinking about that as well in Finland?
Yeah, we have heard of that, and we have a little bit discussed of that. But we have to say that there is no way that we can quit liming because of the CO2 emissions. We count on that the crop plants are growing better and taking the carbon as much as liming is causing emissions, so they are uptaking carbon or even more. So it balances the situation. So it's not it's a kind of out of question that we cannot quit liming because of that. But of course, if there are some kind of solutions to reduce the emissions from liming, of course they are very welcome.
We have another question.
Yes, thank you for the presentation. It was very interesting. I have a question. Do you know any other countries in Europe that has this need for liming in large territories? Okay, we know Latvia and Finland. Are there anybody that are struggling as well?
Perfect. I don't have to do the translation. Thank you so much.
Yeah, that's a very good question. I think Finland is the... Yeah, when we have discussed with EU, we have to always stress that, well, in Finland we have these and these kind of circumstances, and therefore we have to lime and so on. But in fact, I don't know, maybe Ireland, or in fact we have had some similarities with Ireland, but I'm not sure. Anyway, when concerning peatlands, because peatland is another question also. But in fact,
it's Estonians, Latvians, and Finnish. Because also we were discussing about people who we should invite, and the Danish didn't see a problem in pH, and also the Germans. So
but in
it's
Finland
us three.
Yes. Yeah.
Thank you, Sari. Thank you for raising up an issue with cation exchange capacity and importance of including that in soil analysis. And on liming, the question, is there a practice in Finland of using micronized lime as a calcium through leaf application, like the substance that's micronized up to micrometers?
No, it's not so. No, not at all so common. Maybe some experiments, but very interesting to hear more about that. Okay, that's quite new. Anyway, for me, not so much. Yeah. Okay, you can send me. Thank you. Yeah. So it's not so common. We rely on these traditional methods, and there is a kind of very big basic need for liming, and therefore we are using these kind of traditional way of liming.
Perfect. Any other questions? Maira.
Yeah, I have a question about do your Finnish farmers have also some kind of support from the pay from EU payments because the costs per hectare is high. And another additional question, we talked that today in the morning, but maybe you could tell a little bit about the gypsum, why you are doing that in Finland and what kind of support there you have.
Yeah, the first question, farmers do not have or never have had support for liming from EU because it is kind of regarded as a basic farming practice and therefore it hasn't not been included as a support. We have had discussions, but then we have ended up with a solution or a kind of a decision that maybe it's good that it doesn't have support, liming doesn't have support because there's a risk that the support amount which farmers can get, it goes like to the factories, to the liming factories. So if the liming factories know that, okay, farmers are getting support, so they increase the price as much as the farmers get the support. So there is this kind of tendency. Yeah, and the other question concerns about gypsum. Yeah, that's calcium sulfate coming from a fertilizer industry like Yara in Finland, making phosphorus. And in Finland there's now a big project that farmers can have this gypsum for free to their fields, which are located near the sea, very near the shore. And the reason why gypsum, it doesn't increase pH, it brings calcium, and it kind of affects, as I mentioned, it makes the soil aggregates strong and prevents erosion and prevents phosphorus leaching. And that's the main reason that we are using gypsum, and the research has shown that gypsum addition reduces phosphorus leakage. And it lasts about 5 years, the impact, and now there's a big project and many million euros for farmers and for transport and for contractors to deliver gypsum to the fields in the near the seaside of Finland, so in the shores, not inside Finland, but near the sea. And yes, that's a very very big project, and and maybe it gives results. It also affects, of course, the soil structure, maybe increase yields, but when the farmers are getting it for free, we have to be very silent from the positive sides of gypsum and not to mention them too much, because if it has also yield increases, then the farmers wouldn't get it for free. So that's why it's marketing as a prevention of erosion and phosphorus leakage. Yeah.
Okay, thank you, Sari, very much.
Yes.
Applause.
Okay. Yeah, thank you.